Hey, this is Ms. Mendoza. Today we're going to learn or really review solving two-step equations. So I'm going to zoom in so you guys can see what I'm working on better. Make sure you type along with me because this needs to be filled out as I fill it out. Okay? So we have talked about combining like terms. We've talked about distributive properties, so we're going to take it one more step and we're actually going to solve an equation now. Because what we were doing before was with an expression. So the difference between an expression and an equation is that it has this equal sign, and we're going to talk about it in a moment. So before we do that though, let's review what inverse operation means. So inverse operations are operations that are opposite of each other. So inverse means opposite, and operation is operation. And so the different operations that we have are addition, subtraction, multiplication, and division. And you'll find some other ones as you get higher in math. But right now we're just going to focus on these four. So the inverse operation of addition is going to be subtraction. They are opposite of each other. Okay? The inverse operation of multiplication is division. Those are opposite of each other, and I misspelled division. Okay? Those are inverse operations. So when we're solving a two-step equation, really any equation, the goal is to get the variable by itself. And you're going to hear it like this, or you're going to hear also isolate the variable. And that's just like a really smart, fancy way of saying the same thing. Okay? So if you want to sound smart when you're answering your questions, which I know we all do, then you're going to want to say isolate the variable. But getting the variable by itself is the first and the main goal of solving equations. The other thing that we have to remember whenever we're solving an equation is that what you do to one side, you must do to the other side. Okay? So what you do to one side, you must do to the other side. And whenever I say that, some of my students are like, Miss, what are you talking about? So we're talking about the equal sign. So what you do to one side of the equal sign, you have to do to the other side of the equal sign. And some of your former teachers might have taught you to draw a line through your equal sign. And that way you know that when you cross the line, what you do to one side of it, you do to the other side of it. So let me draw a line here just to show you what I'm talking about. So some of your teachers told you to do it like this, right? You draw a line. And so what you do to one side of the line, you do to the other side of the line. Another thing I heard is cross the line, change the sign. That's just talking about inverse operation. Okay? All right, so we're going to go through these examples. We're going to use Algebra Tiles at first because I want you to kind of picture what we're doing. So I'm going to draw a little equal sign. And I'm going to duplicate that because I want to draw equal sign. Okay, and then I'm going to model it using my algebra tile. So remember, our x's are represented by these long ones. Our numbers are represented by these. X is positive, so I'm going to use the yellow one. So I'm going to drag it over. So I only have one x, so that's all I need. And then I have plus 2. So these are supposed to be like a really pretty square, but it looks kind of deformed, but it's okay. So I'm just going to drag one and then duplicate that and move it over. So x plus 2, that's what this is because they're all positive, equals positive 3. So I'm just going to move another one over. It'll be faster if I do it this way, yeah. And I need 3 of these, so I'm just going to duplicate it. So Control D, that gives me 3, all right? So I already modeled this first equation. So this is telling me x plus 2 equals 3. And this is all in yellow because all of these numbers are positive. Okay? So then we're going to make a zero pair. And the reason we want a zero pair is because we want to isolate the variable. So that means that I'm going to focus on making a zero pair on the plus 2 because that one is on the side of the x. And remember, I want x by itself. So in order for me to do that, to make a zero pair, I need to use my inverse operation. So if I have a plus 2, then my zero pair would be minus 2. So I'm just going to add it to this one. Okay? So minus 2. So what I do with one side, I must do to the other side. So I'm going to duplicate this one, so Control D, and move it to the other side of my equal sign. I'm going to do it again. If I'm going too fast, you can pause me, guys, and you can take your time. So this, whenever I do that, I isolate the variable. And so I have x, I moved it over, so now I'm left with x on this side. And then on this side of my equal sign, I am left with 1. So I'm going to duplicate this and move this down. Now I've accomplished what I wanted, which was I wanted to make sure that I isolated the variable. So I'm going to duplicate that. So what am I left with? I am left with x equals 1. Okay, that is what I'm left with. So that is my answer. I just solved this one-step equation. And I know it sounds a little bit complicated and hard, but I just wanted you to visualize it. So really all I'm doing is I'm subtracting 2 to both sides because I want x by itself. So minus 2, this cancels. 3 minus 2 is 1, so x equals 1. Okay? All right, let's do one more. Here it's a little bit different because our x's are the same. So I'm going to duplicate that and move it over. But instead of a plus 2, I have a minus 2. So I'm going to take one of these red ones, or 2 of these red ones, actually 1, and then duplicate it and move it over here. Okay, so now I have minus 2. And then I'm going to duplicate this one, the equal sign we created, and I'm going to move it over here because on the other side I need positive 3, so that's going to stay the same. So I'm just going to take one of these, Control D to duplicate, and I'm going to move it over. All I'm doing is using my arrows to move over, and then I'm just going to do 3 of them. Okay, so now I have to do the 0 pair, but because I have a minus 2, I have to use inverse operation. So instead of using the negative 1 like I did here, I have to use positive. That is my 0 pair. It's the opposite operation. So because I have negative 2, I have to do 2 positive units, right? And so what I do to one side, I have to do to the other side of the equal sign. So I'm going to duplicate these and I'm going to move it to this side because I have to do it to both sides. Okay, now what am I left with? So on the left side, I am still left with x, right? I still have my equal sign. So all I did was drag it and then draw a big, like a box around it, and then Control D and then move it over with my arrows. But how many ones do I have here? 1, 2, 3, 4, 5. So instead of having 3, now I have 5. So 1, 2, 3, 4, 5. So what is my answer? So the value of x is now 5. Okay? And I got this answer by just using inverse operation. So if I type this out, I'm just going to take this one instead of getting a new text box and duplicating it and moving it over. So x equals 5. Okay, so what did I do? All I had to do was use the opposite for it to cancel out. So instead of minus 2, I did plus 2 and then I moved it over. So x equals 5. All right, okay, so now let's look at our two-step equation. Here are our steps. Move the constant using inverse operation. So constant is a number without the variable. So we're going to start with that one first. You want to start with the one on the side of the x because what is our goal? Our goal is to get the x by itself by using inverse operation. So those are our 2 steps. You're going to move the constant and then you're still going to make sure that you use inverse operation to get x by itself. All right, so let's start with this one. So I already have 4x. So I'm going to start with the plus 7. I need to do the opposite operation. That means I need to subtract 7 and subtract 7. Okay? What am I left with when I do that? So on this one, I'm left with 4x equals, and then 27 minus 7 is the same as 20. Okay? So I still have a number in front of x, it is not by itself. So I have to use inverse operation, so the opposite operation. So remember what we said about our number with a variable when we were looking at distributive property. We said, and I'm going to go back real quickly so you guys can see, that when we have a number with the variable, it means that, we're here, a number with the variable, it means multiplication. We are multiplying it together, okay? That's what that means. So if we have 4x equals 20, the opposite operation of that is going to be division, because we said that the opposite, because we said that multiplication and division were inverse operations. So we have to divide both sides, because what we did on one side, we do to the other, by the number in front of x, which in this case it's 4, because we want x by itself. Okay, so then what are we left with? We are left with x equals 5, because 20 divided by 4 is 5. And that's how we do that one. Okay, let's do another one. This one's a little bit different, and I wanted to put it in here on purpose because I wanted to show you how we do something like this. So the first step is the same. I have minus 2, so I need to do the opposite operation, which means I add 2 to both sides, because minus 2, the opposite is plus 2. So what am I left with? I am left with this same number here, and it's going to look a little bit different than what you see. So x divided by 5 equals 8 plus 10, excuse me, 8 plus 2 is 10. So fractions are division. So you heard me say x divided by 5. Yes, fraction is division. So whenever we have something like this, where there's a 5 and an x on top, we're going to do the opposite of division, which is multiplication. So I'm going to divide, I'm going to multiply both sides by 5. So on this side I multiply by 5, and then on this side I multiply by 5. So remember, when we have parentheses like that, that means multiplication. So what happens to this number? So what happens on this side is that it ends up just canceling out. So it goes away. Oops, it won't do it. And we are left with x equals 10 divided by 5, which is 2. Okay? All right, you are going to try this next example, 2 examples by yourself. I'm going to add a text box for you to show your work here. If you have a question about this, please make sure you ask us. These two are exactly the same on how we solve them. It's just a little bit different on the steps, but you should be able to get them. Okay, so go ahead and try these, and then you're gonna go move on to your independent practice. I hope you learned or reviewed on how to solve a 2-step equation. Make sure you turn in all your work.